Welcome back to VTU e-Shikshana program on engineering drawing, computer-aided engineering drawing, module 2. So far we have discussed triangular lamina, pentagonal lamina, square lamina, and also hexagonal lamina in case of laminae. In case of prisms, same type of shapes are taken and discussed. Last session we worked out pentagonal pyramid. This time we will work out hexagonal pyramid with various conditions. Some criticality of the problem we will discuss. Now we will take one problem on hexagonal pyramid of base edges 30 mm and axis 60 mm long, has its base edges on HP such that the axis is inclined at 30 degree to HP and appears to be inclined at 45 degree to VP. Just for a change I have given, otherwise I would have taken inclined at 45 degree to VP. We will discuss that also. Now we will take a model. This is hexagonal pyramid with 6 sides, 2 parallel sides. Whenever you check, 2 parallel sides will be there. And also edge condition is the edge to be placed on HP is parallel to perpendicular to VP. Okay, perpendicular to VP. So let me take this simple model and discuss. This is hexagonal pyramid having 6 base edges and slant faces. These are called slant faces. These are slant edges. In case of pentagon, we discussed corner condition. Now let me take edge condition for the hexagon. Same problem you can work out pentagon also with the edge condition. Now, first position is this. It rests on one of its base edges on HP. So, edge to be placed on HP is always perpendicular to VP. Say, this is perpendicular, I will keep it like this. Okay, now, second position is tilt it like this. Axis inclined at 30 degree to HP. And the axis again inclined at some degree to VP. It can be like this or like this. Base is towards you, that is observer, and base is away from the observer. Or they may give alternately, instead of axis inclination, they can give inclination to the slant face. Once you draw the front view in this position, you will get this as a line. You can incline that line with respect to the given value. Say the slant face is inclined at 50 degree to HP. First position, second position. Then they can give inclination to the base edge on HP or to the axis itself. So I have given axis inclination now, first position, second position, third position. So axis inclination can be given or the edge on HP is inclined some degree to VP. Then 2 length on 2 inclination. Here you consider beta because axis reference is there. Okay, now let us work out that. Before that, let me give some important information regarding the front view. So normally top view, front view are important in pyramids. Basically, the slant edges are drawn as diagonals in case of square and the hexagon. Normally, people never dark that. Okay, now I will give a simple figure and explain how to start working in this. Now edge condition, so I assume that I have the top view like this. Okay, now how to dark this? What are to be darkened? Actually, you have to draw this and also this. Fine. Now draw dark lines for this. This is V, O, A, B, C, D, E, F. Now project this and get the height V dash. This is A dash, B dash, C dash, D, E, F. In sequence I get, just because I have started with the left extreme nearest corner. Now join this. Now what all to be drawn? Dark. See, normally we complete this. So now this is identified as axis. This is wrong because VB is visible and VE is just backside of VB, that's why it coincides with that. There is no scope for axis here, so you must draw dark line. This is very important information for you. Now the slant edges which are appears as diagonals must be dark, because these 6 lines starting from V to all corners representing slant edges. See, these are the slant edges. If you look from this direction, print on VP, what you get? Hexagon with lines joining all corners with apex, that all are visible. Okay, suppose that if I keep it like this, just axis perpendicular to VP, okay, and you never get the slant edges visible, but hidden lines you have to draw. So in this case, it's a very simple case. We are going to keep the solid with its base on ground, and all the slant edges are dark in front view as well as top view. Okay. So let me take this model and work out the visibility of the slant edges. If I keep it like this, axis perpendicular to VP, all slant edges are visible and all corners and edges are visible. Lines joining all corners with the apex are visible. Suppose if I keep it like this, then you can see only base surface. But how to represent the slant edges? That is by dotted lines. Same type, the dark lines replaced by dotted lines. Okay, no scope for axis here. Okay. Now let me continue with the actual problem. Hexagonal pyramid of base edges 30 mm sides and axis 60 mm long has its base edge on HP. So the item to be placed on HP is always perpendicular to HP. That we have discussed lot many times. Now let me start with, assume that I have worked out the top view as hexagon A, B, C, D, E, F. Now as I told you earlier, you must draw dark lines for the slant edges, that is starting from apex. Now if you draw diagonal, that helps you a lot to understand the slant edges. Yes. Now you can say this is VO, that is apex, and this is base center. Now let me draw the top view and front view. So project. This is base center A, B, C, D, D, E, F. In order, we have A, B, C, D, E, F are not visible. Then project only the center, base center, and fix the height. 60 mm. This is 30 as per the given dimension. So join these points. So this is very important line. I have drawn axis already, but VB is visible. VE is available but not visible. Okay. This is very important. I am stressing this point because majority of the time we observe this is missing from the solution. Now the dimensioning. Always keep away from the figure. Comfortable presentation must be there. Now top view of the solid, front view of the solid. When you have base edge on HP, you must keep edge condition. This is edge condition with respect to HP. So I start from the basics. Since the axis inclined to HP you make it perpendicular to HP so that you get the true shape of the solid on HP. Okay. Now, if I incline like this, the axis inclined to this is normalized position. Then tilt like this. First position, second position, third position, or third position. Let us discuss both in detail in computer. But here let us work out the basic problem with the base towards observer in the last position. Now, let me take the inclination reference. What is inclination given? 30 degree to HP. So, if 30 degree to the axis, base inclination is 60 degree. So, let me take 60 degree line for the base, and then take the same distances. Here I have this point and this. Okay. Now draw perpendicular. Manually you can use set square or small protractor to give the height of the solid. Height of the solid is 60. So it is available now 60. Take height of the solid 60. But people use arc method also. Take this two as same radius, these two as centers, draw arc, but that gets you some problem. Here it's easier. Anyway you are fixing. How to fix these points? You take only one radius, draw two arcs. You will get O and this wave center and then this point. Now name it clearly: A dash, F dash, B dash, E dash, C dash, D dash. Join this. So this is about the second figure front view. So this is second figure front view actually refers to the inclination of the solid with HP. Now requirement is for the axis. So draw dimensioning reference. You can have this reference 30 degree. Actually you have taken 60 degree to the base. Now V dash, O dash, V dash, O dash. This is axis. Now again this is not covered, assuming that it is always axis reference, so it should be dark as in the first figure. Yes. Now this front view, second figure front view is completed. How to get the top view of the same? Now, as I told you earlier, better you draw two lines, that is extreme right projection, lowermost projection, bottommost projection for the base only. Now project up to this acts as stopper, again this. Now this is again the top view of the base, top view of the base. Yes. So let me project these points, and the apex point project up to this and draw again. Now it's easy to identify. This is A, B, C, D, E, F, base points. Then this O. Now visibility of all the edges, slant, whether slant edge or base edges. Let us see. Join all these points with light lines first. Light lines and V to F and A to E. All corners of the base must be joined to with the apex. Then you are looking from this direction, which is the farthest item from you, that is CD. CD CD of base side, base edge CD is the farthest item from the observer. That is not visible. Let us think of using farthest item from the observer. Then think of key surface method. If it is feasible, easy, we will work out that only. Yes. Now there is no confusion. Then start with this and continue. Now this is not visible. That is, item CD is not visible. Number of lines joining this particular item are not visible. That is, BC, VC, VD and DV are not visible. It is well within the boundary. You can as well use this. Easiest method is the farthest item method for this particular second figure top view. Let me do that. Yes. I have covered all the invisible lines. I will repeat. CD is not visible. Base edge CD is not visible. And any number of lines connecting to that item. Item means here it is CD. To end C, CB and CV are connecting, and DE and DV are connecting. They are well within the boundary. No confusion. So start and end with farthest item method. This is invisible lines. All the remaining lines are visible. That's what. Very simple procedure. So dark all the lines. Now as usual, you are going to keep the boundary dark. Okay, all boundary lines are dark irrespective of the situation. Okay. Yes, all boundary lines are dark and all remaining lines are dark. Then you can interpret the same with the key surface method also. Now I will just, this is over. Now let me discuss the key surface method, which is the nearest key surface. No nearest surface, it is only apex. It is pyramid, only one key surface. The key surface is not visible. Then skip that procedure. Second one, boundary lines are dark. Yes, boundary lines are dark. Then invisible key surface, it is there. That is not visible, but all the boundary lines are visible. So the edges of the invisible key surface other than boundary lines are dotted. Yes. Next, this is invisible bends, this is invisible bends, this is crossing line or invisible surface, visible line. That's all. So this particular type of completion of solids projections is very easy if you have both the concepts. No confusion at all. This is by farthest point method easier. Next comes the inclination with VP. So he has given the axis appears to be inclined at 45 degree to VP. See, this axis is apparent length now in this case. This is apparent length. So this must be placed on apparent inclination. So apparent length on apparent inclination beta, since OV is apparent length in second figure top view. Okay, in second figure top view. This is the reason why we are going to consider beta. Okay, we will ask many times why beta, when beta. Now this is the answer. Now again there are two cases, alternate solutions are there. One is the basis nearer to the observer and basis away from the observer. Now I will again take this model and explain. Purposefully I have made this base dark, that is colored one. First position, second position, third position. Okay, first position, second position, third position. So base is completely visible. Okay, that is nearest surface is base, key surface is base. Then the farthest item from the observer is apex. Then there will be confusion in keeping. Now in that case, for finalizing the final front view, you can use key surface method. So now I can start working for the final front view and top view. So how to redraw this? You know, it's easier if you have clear idea about geometry, redrawing geometry, particular figure. So 45 degree line. Then take easiest method is take VO manually. I am keeping in case of this computer, you can move and rotate. Now I am taking VO first. Assume that I am taking VO first. Then you are supposed to take one more distance. This distance. Let me name this as MN for time being. You not name it. I assume that this is M and N. Both are equal. This is O, M, N. That's all. This distance equal to this. Then draw perpendicular. That's all you have to do. You have to take only two distances now to complete the figure. What are those? See this. Only two distances you have to take. This distance, and also this distance. Now let me transfer this distance here. If I take one distance that works for 4 points, that is A, C, D, F, I completed. Now OB and OE completed by taking only one distance. Maximum of two distances I have taken, and only thing is you have to carefully draw perpendiculars there. Easy. If you manually, if you use small protractor or the set square, 45-degree set square with protractor, it's easier. You can do it. Now draw the thin lines because of number of lines are there. It's not to confuse. Join this. Yeah, same figure you have to redraw. That's all. Yeah. Yes. So this is dotted. So as per the discussion what we had earlier, the base is towards observer, away from the, here its base is nearer to the observer. Let me name this properly as per the previous top view. A, B, C, D, E, F, O, V. Now how to get the final front view? First draw all the points. So unnecessary projections you can avoid by just keeping on their specific locus. Now I have AF is the topmost point, AF, and on XY itself you get CD. The middle one is E and F, B and E, actually B and F. This is E dash, this is B dash, this one is C dash, D dash, F, A. Okay, V dash. Join them in order A, B, C, D. But be careful, neighboring intersection will be there. Sometimes you will be marking in the neighboring points. That gives you wrong answer. Then A, F, B, C, D, E. All these points must be joined with V. Now, yes, I am here to complete the final front view. Whether we go for farthest item method or the surface, key surface method. I prefer key surface method because farthest point is V. Fine. V is not visible. Fine. All lines joining the point of X are not visible. There are boundary lines, fine, I can accept this to be dark. But what about other points, other lines? There will be confusion whether to draw dark line or line. But key surface method is very easy. The basic procedure number 1 is nearest key surface is base. Yes, draw dark lines for all the key surface edges. Very interesting, easy also. Boundary lines dark. Second procedure is boundary lines dark. Already 1, 2, 3, 4 lines are covered by the boundary line because it is part of the boundary line, base edges. Now, third procedure is invisible key surface edges are not visible. No question of invisible key surface because this is pyramid, only one key surface is already we have covered. Now, the rest of the procedure is very easy now, either crossing line or bends or visible surface, invisible line, that's all. Now, see, EV is dotted because it is invisible surface, you cannot have visible line or crossing line. Okay, this is dark line already, you cannot have one more dark line passing through that. Again, this is dotted line because it is visible surface, invisible line. Now, what about AV? The only one line left. AV is again the dark line because of bends. Bends or crossing line or visible surface, invisible line, invisible surface, visible line. That's all. So, this completes the solution, and VO is the axis you mark it as per the convention only for that particular reason, that is length. Now, same thing you project onto the front view, that is along with the BC, B actually should be here, B O dash, again complete that with convention. Okay. Use 0.2535 in computer with the third line, actually third type of line, that is how dotted line with full line. So, this is how we can complete the solution for the given problem. But same problem, if I give directly 30 degree THP and inclined at 45 degree TVP, you have to find beta. Here we have given beta equal to 45 degree. There, in that case, you have to see axis inclined at 30 degree THP and 45 degree TVP. If I add, then you will be having what? Beta degree. That procedure you have to follow and find beta, you will be getting around 55 degrees. Suppose that slant face or triangular face containing the edge on HP is inclined at 50 degree to VP. See, this is this particular line representing the slant face. Here, if I keep the edge condition, this particular surface is going to be the triangular face or slant face. In regular position, this is slant, having some slope. That's why it's called slant surface. Now, this particular triangle itself is inclined at some degree to instead of axis. So, the point of interest is only slant face, not the axis. Now, take this line and draw 50 degree line. Once you move in computer, this is the first figure, second figure you move here, you draw from this point one line, 50 degree line or whatever, here he has given 50 degree, then you rotate this such that this is placed there. In this case, here what you do is, I will repeat this particular problem. Here, what exactly you have to do, here only I do it, part point BC, here B dash C dash, fine. Now draw 50 degree line, then take this distance mark, okay. Then this is isosceles triangle, this distance equal to this, draw an arc. Again take base center, draw one more arc, join this. Then mark midpoint, join this. This gets you the front view. Same solution. No, there is no change. Particularly this particular problem, here you get 50 degree. That's why I have chosen 50 degree. It may be small changes, 51 or 49 something. In otherwise, procedure is same. That we will discuss in the computer. Let me discuss some of the basic aspects of hexagonal pyramid, particularly the front view, top view in basic positions. That actually very much essential as initial conditions for the regular problems. Now let me take up a simple position. Hexagonal pyramid of base side 30 mm and axis 70 mm long rests with its base on HP, such that the base edge is perpendicular to VP. There is no inclination to HP, it is simple position, base completely resting on HP and two of its edges are equally inclined to VP. Okay. Now two of its edges equally. I will explain what exactly this means. Here one of the base edge is perpendicular to EP. Or in this particular case, hexagon, we have two parallel sides. This edge is perpendicular to EP, means this is also perpendicular to EP. Or they may give two base edges or simply one. If one means, naturally you will get two. Okay. Now, what about the other one? That is, two of its base edges are equally inclined to EP. That means AB, BC or EF, ED are equally inclined to EP. Either you can consider this or this. Both are going to happen. In both the statements gives you the same answer. Okay. So now, if I draw the lines with all thin lines and project it, you will get this. But how to identify whether dark line or full line? As I explained earlier, you have definitely all the base edges are dark, because if you look from top, all base edges are visible but not the base surface, because they are common to the slant surface. Now, naturally the edges, the extreme edges you draw dark, but you miss this line. You treat this as axis because you concentrate on axis. Axis is having third preference. One is dark line, visible line, then invisible line, then third preference is for the axis. Here the visible line is VB and invisible line is VE. V is coinciding with VB. This is the correct figure. So, you have to dark all the base edges, including slant edges. See, VA, VB, VC, VD, VF are visible, because you need not have to concentrate on individual lines here. If you draw diagonals, all the three diagonals, it works out. You will get naturally the slant edges projection in top view. Only thing is you have to mark V and O. O is base center and V is top center of the axis. Now, this is front view. This will be missing, and also sometimes this will be missing. So, naturally, this is the complete projections of the simple position, top view, front view. Now, same thing will be the initial position for the next problem for us. Now, let us see what is the next problem. A hexagonal pyramid of base side 30 mm and axis 70 mm long rests with one of its base edges on HP, and the axis being inclined at 30 degree to HP and appears to be inclined at 45 degree to HP. Draw the projection. So, this is what the statement given as per the problem definition statement. And you know, axis inclined to HP, first you have to consider the HP inclination with the axis. Once the axis inclined to HP, make it perpendicular to HP so that you get the true shape of the base of the pyramid on HP. Yes, edge condition. What is the condition? The condition is corner condition or edge condition? Edge. So, definitely item to be placed on the ground is always perpendicular to, okay, VP. The item here particularly refers to the edge if it is, say, if it is perpendicular. If it is corner condition, then you have the diagonal parallel to VP. That diagonal must pass through the corner to be placed on HP. That you know in case of laminate and also the problems which you have done already. Now, how to get the inclination to HP? You know, by this time you are having clear idea that you move and rotate in computer. You move to the side, the right side, then forward direction, and keep CD as a reference, and then rotate the base so that you will get the inclination to the HP. How much inclination you have to give to the base? So, theta B plus theta A equal to 90. Theta base and plus theta axis equal to 90. Naturally, you will get 60. So, you will be having the inclination 60 degree to the base. Naturally, you get 30 degree to the base. Then project it to get the second figure top view. So, second figure top view, as I explained earlier, you must carefully do the unnecessary lines you can avoid by using alignment indicator. So, what I did was, I took only this line first, then I marked. Then I took this A, C as a reference, and then alignment indicator I marked it. Then you project on the respective lines, that's all. Only one line is enough to complete the V position, that's all. Next, complete this visibility line, you have to identify. Next, if I look from top, the item, farthest item from you is CD, base edge CD. That is not visible, right? Then any number of lines connecting to that are not visible. Farthest item method I use now, because all the edges which are coming under this category, that is invisible category, lies within the boundary, not out on the boundary or any other line. So naturally you are going to draw this line with the dotted hidden line concept pattern. Okay, 0.5 only you have to do hidden line, that is invisible. If this is invisible and number of lines connecting to this are CB, CV, CD and CV. See, this is how you analyze. Base edge CD is the farthest item from the observer. CD is not visible. What next? Then the sides CV, CV, DE, DV are not visible. That's all. So this is first phase of the procedure. Second phase is all remaining edges are visible. Okay, all remaining edges are visible. I have made all remaining edges visible. Whether slant edge or base edge, don't worry. All edges are visible. Next comes the inclination to the VP. Since he has given beta, this apparent length, no doubt, instead of 60, 70, 70 has become 60.62 because of this inclination. Definitely this is apparent length or apparent inclination, that is given because appears to be is given. So definitely you can keep that this figure says that VO is on that line. Okay. Now as usual you project and get the points, then join all corners with PC. Then here again I discuss this which method you prefer. If you prefer the extreme farthest item from you is V, and in case of V, say there are many lines. See, 6 lines are there. Which one is dark? I can assure that boundary lines are dark, but I cannot say this is line is dotted, this line is dark, because of that imagination and nearest surface references we can have, but everybody cannot have. So what I suggest is keep this boundary lines dark, after the visible key surface dark, keep boundary lines dark, then the boundary lines dark, then go for visible bends, that is here A to V is visible, B to V is visible. Okay, so you dark those two, or you can also prefer visible surface, invisible line. Yes, you can do. See, visible surface, invisible line. I have done that job. See, visible surface, invisible line. Next comes these two lines. What about these two lines? AV and BV, they are definitely visible because of bends. This AF is visible, AB is visible, definitely one more line joining, that also visible. Okay. So, or otherwise in farthest item method, then one has to look for visibility nearest to observer, etc. It's also easier. See. And in case of farthest method, only these two are dotted, so we cannot easily identify that. In case of base nearer to the VP, it's easy for you to do that. Now I hope all of you understood what exactly the concept of visibility, either a farthest item method or the key surface method. Okay, you can complete. Now this is final solution for this problem. The axis inclined 30 degree to HP appears to be inclined at 45 degree to VP. Okay. Now next problem is directly the inclination is given, no appears to be business here. It is direct 30 degree to HP and 45 degree, as though the line is inclined to both the planes. Now in that case you have to find beta. In this particular case the axis inclined 30 degree to HP and 45 degree to V, you will get 55 degree as the beta. I have given the procedure. And then after doing this procedure, I have taken move and rotated it. Then I got this one. Then as usual, you get the final view. So you try to work out for the final view. Same type you get. There is no change. Small changes will be there. Okay, procedure is same. Okay. Now concept I have given. This is the reference for hexagonal pyramid problem. Hexagonal pyramid of base side and 70 mm long rests with one of its base edges on HP, axis inclined at 30 degree to HP and 40. Directly it is given, so you have to find the beta and then do it. Next comes the triangular slant face, which is inclined at 50 degree to HP. What you have to do is you have to move and rotate. Once you start move and rotate, then there will be problem of fixing this. VDC is inclined at 50 degree THP. For that, what you do is draw a 50 degree line and then move and see that CD is on that line and then rotate on that line. So you need not worry about the angle, simply rotate till it reaches that line. Then the solution for the same is this. Okay, so 50 degree slant edge inclination to HP, then the solution you get as usual. You have to follow the procedure as per the information. Then the information is here, the slant face or triangular face is on HP. So what you have to do is completely you rotate, so that you move and rotate such that CD is resting on the HP. Okay. Now the top view will be the A, B, C, D, E, F is the base, and then this one. If you look from this direction, the top base is visible. Okay. So you can have base surface dark, then boundary dark, then the bends, visible bends, then visible surface, invisible line. The same procedure is to be followed here also. See, what I do is I will keep this procedure on now. Now what I do is I will start working for this particular problem. Now I am here. Observer is here. Let me follow the visible key surface method, because the farthest item is the triangle that is not visible, and also many lines are joining. Okay, if it is well within the boundary, fine, otherwise it leads to confusion. Now what I do is I will take this particular figure and then explain. Now visibility concept, dark all these lines. Now I will select this, all the boundary lines are dark and visible surface dark. First visible surface dark. .5 dark line, yes. The next procedure is boundary lines dark. I select this CV and BV. They are dark again. I will make those lines dark. Yes. Then there is some problem here. I will sort it out. Now it has, so earlier it was like this. You may face the same problem. I don't know why it has happened. Select this. I will repeat. Select this. Make it dark. Yes. Then select these two boundary lines dark. Yes. Then this AV and FV are dark lines because of bends. Simply bends. They are dark. Then DV and CV are not visible because visible surface, invisible line are crossing lines. Crossing lines cannot be of same pattern, different pattern. So select these two and then 0.5, then invisible, that is hidden line. Yeah, that's all. Then what is the axis position? There is any scope for axis? Definitely there is full scope for axis representation O to V. So what you have to do is select this axis. Here is complete line is there, better to split this. So to split, go to split. Sometimes you may get some trouble, but otherwise you can do it. See here, yeah. Now you can see this becomes different entity, separate entity. Now you select this and then see that this is different type of line. Now this is axis line, 0.25 or 35 axis line. Yeah, this is how you can complete the second figure top view. So finally, what you have to do is you have to see that the base edge on HP is inclined at 45 degree to VP. So all this time what we had axis inclined at some degree to VP, etc. Now which is the base edge on HP? So here the triangle CDV is on HP. Definitely, see this line represents the CDV line on HP because it is perpendicular to VP and on HP. That's why it's line. Now this is true shape. CD is the true length. He wants this particular line CD inclined at 45 degree to VP. That's all. Now let me do that job. Select carefully. Yeah, select carefully. Move. Take this point somewhere here. Here. Yes. So that you can keep the base towards observer. Yes. Okay, we can move further if there is any problem is there. Space management is important here. Now, see that this CD is inclined at 45 degree. This is what the base edge. Say out of 6 base edges, CD is one of the base edge. This is part of this triangle which is on HP. He wants that edge inclined at 45 degree to EP. So, rotate command, rotate this C about CS center, rotate CD 45 degree. So, see that this is blank. So, that and 45 degree either with the vertical or horizontal. Yeah. So this is how you get. Now since it is crossing XY line, if you draw continue this line, you have to move further. Now what I do is I will select this and then go for a new sheet. Yes. Now I will move again further. I will keep Vy that side so that I will get only this figure down. Yes. Move. You have to do these adjustments if the problem of space you are facing. Now we will make this right to the required position. Yeah. Now you project up so that you will get the solution. I will show you how to do it. Okay. Now this is V. Somewhere it's missing. Okay. Now project the base points only from second figure front view. See, I will take A as a reference. A. It is something like marking the points manually. Here you are using mouse. That's all. A. B. Second point. Yeah. Then C and D. It is on XY line only. This is C. This one is D. Then we have F at the last line. Then we have this C is missing here. C. E. E is missing here. A, B, C, D, E actually. This is E. Okay. Now this is E dash. This is F dash. This is A dash. This is B dash. This is C dash. This one is D Now, yes. Now what next? The point to be projected is onto xy line only. Okay. By chance, if you take this as O1, then you will be having the chance of projecting up to this. It's not correct. Now it is only up to xy line. Okay. Only up to xy line. This is V dash. Mark this as V dash. Join all corners of the base with V. Before that, let me join all corners. Starting from A, you seek for end point reference is always good. Otherwise, you will get some midpoint of some other line, etc. So always you look for end point reference. Now join all corners of this with V. Sometimes you may face the nearby points or midpoint or some intersection, then it will go there. But very carefully zoom and do it in that case all the time. That's all. Then DC and DV and CD are coinciding each other. Okay. Now the reference is here. I have the yeah. I'm here. Okay. Let me identify that. Identify that visibility concept. Visibility concept. Take this. Base is near to the observer. It is visible in top view as well as in front view here because the face is facing the observer here. Now take this and dark all these points, lines, edges. All base edges are visible. All base edges are visible. Okay, next, all boundary lines are visible. Select all boundary lines. Okay, if I select all boundary lines, this also the XY line only will be there. So what I do is, I will select only this. You may face the same problem. What you do is, you take only that line first and then create one line extra with the line thickness 0.5. That's all. Otherwise, the entire XY line will be dark. Okay. See, up to this only you draw. Yes. Now I have drawn visible key surface dark, all edges, and then boundary line. Then the problem here is the visible and invisible edge from this portion to coinciding. Don't worry, keep BV first, visible. BV, see this midpoint and all is there. You go to IntelliSketch and switch off this midpoint and all. Otherwise, it creating problem. Okay, okay, say okay. Whichever you don't know, you never get that midpoint. You get point on the ground. Better you get intersection or end point. End point is the best. Now, see this is visible bends. Okay. What about this FV and EV? FV from this point to the V is dotted, but already it is covered by the boundary line, visible line. Then this portion to this portion you dotted, keep dotted. Now select this line, and in computer you can select dotted line only. You never get any problem, but can split and do that job. See, okay. Now this point, this line, that again it is dotted because it is crossing line or visible surface, invisible line. Then axis, finally axis, thin line, You select for projection, and this is on BC line, then say O, O dash. Join O dash with V dash. That gives you the axis reference, that is third line in the row in this case. Yes, 0.25 or 35. From this point you draw this. Yes. See, this is how the axis reference. Now that's completed, solution is completed, and like this you can work the pentagon problem, which is having slant face on HP, triangle. Already we worked out on problem on square, same type. The complexity here is the coinciding lines are there, you can split and do it, otherwise even you can keep this line override so that the hidden line is not visible from this point to this point. Otherwise, this is the final solution for the given problem. Then we will work out some more problems in the next session.